These are 10 techniques which come from the Dummies book. So we're going to go through each of these 10 strategies. So number 1 is to use the enter key. I know that sounds really strange, but when you are building your model, get into the habit of using that enter key rather than clicking somewhere else. So let me show you what I mean by that. So if I jump over into Excel now, so here's an example of a formula that I've built. So I've built the formula, and when I'm finished building the formula, I'm gonna hit the enter key, and that means that I am deliberately putting that number into the formula, so then I can copy across and down and check that it's right. But what I often see people do is that they've finished editing the formula and then they click somewhere else and they haven't looked at what they've just put into the formula. It's important to be really deliberate about, yes, that is the formula. Yes, that is what I intended to do, rather than to, for example, going to here and then click. So most of the time you'll get away with it, but every now and then that can happen and you click and Excel accepts it and you end up with an error without realizing it. So always try to be really deliberate about entering the formula into Excel. So that is number 1. So get into the habit of doing that. So once you have hit that enter key, look at the formula. Does it look right? Does it look correct? So just really kind of, after you've hit that enter key, does that number look like it's right? And when you've checked it a couple of times, check it again, copy across and down, go back, check, use the F2 shortcut key, even use an offline calculator to sense check it and make sure that those values are correct. So for example, you would do a bit of so I've copied to here, I've gone Control C, Control Shift, right arrow, Control Shift down, enter, so copy it, go along. F2, just making sure that it's picking up the right values. Okay, so that is checking it again. And when you have checked it 3 times, have someone else check your work. So when you've finished your financial model, you've checked it, have your colleague check it before it gets published. I used to have a bit of a deal going with one of my colleagues. I'd say, look, before we send our models away or let anyone else, that we send them off to our boss or off to another department, that my colleague would look through my models and I would look through her models, because it's really not very exciting. It is certainly not the sexy part of financial modeling. It's far more fun to build your own models from scratch, but having going through somebody else's models is really not a huge amount of fun, but it is a necessary part of reducing errors in your model. So have somebody else check your work. That is definitely my recommendation. Number 5 is to document and validate assumptions. So we will talk a little bit more later on about validation of assumptions, but financial models are garbage in and garbage out. So if the assumptions that go into it are rubbish, the outputs are going to be rubbish as well. So it's really important to clearly lay out and document those assumptions for any decision makers who are using the model output. So it's absolutely terrifying if somebody says, hey, we're going to make this multi-million dollar decision based on the financial model. So it's really important that those assumptions are really valid, because you cannot make decisions on that model unless you're absolutely sure that the calculations and the assumptions are correct. Because if you are accepting the output of the model, then you are accepting the assumptions that go into it as well. So that's an important part of financial modeling. Next is documentation. So document your methodology. Now don't leave this to the end. So make it really clear how you calculated something. Now this is really important for logic errors. So this multiplied by this gives you this, and then you take this from here, and then you calculate this here, and even to create a flow chart, something like this, so that someone can see exactly how the flow of the calculation works in the model. So I don't always do this, but when it's really important, it is good to show exactly the methodology of how your calculations are working through the model. Another important point is to stress test your model. So I'm not talking about scenarios or sensitivity analysis yet. That is important. But stress testing is when you put nonsensical inputs into your model. So for example, if your price is set to 0, I mean, obviously, you're not going to build a model that has 0 for its price. I mean, we wouldn't do that. We wouldn't sell something for 0. But if you were to input 0 as your pricing, then your revenue should be 0 as well. And if it's not, you'd want to know why that is not the case. So a couple more examples here. Double the headcount. Do the staff costs double as well? Change the growth rate to 0. Would you do the forecast remain flat? Another a great way of checking and testing, particularly with stress testing, is to chart. F11 is your shortcut that's going to give you an instant chart. So it's perhaps not something that you would show anybody, but it's something for you to make sure that it looks sensible. So metrics like cost to serve, or price per unit, or profit margin, or return on net assets, or any of these kind of metrics or ratio analysis remain constant over time, and if they fluctuate, then you'd want to be able to explain any anomaly. So this is another really good check that you can do. Next is scenarios and sensitivity analysis. So scenarios are when you have a whole series of events changing. Best case scenarios, all the numbers change. Base case scenario, all the numbers change. That's scenario analysis. Sensitivity analysis is when you tweak one or two variables independently, a little bit like you would in stress testing, and see how that would change. So let's have a look here at a scenario analysis at a fairly high level. So let's jump over to into Excel now. So here's an example where you've got your net profit here and your profit margin. So we've set up all of these cases. You've got a drop down box as you change. Now I know a lot of people, when they do scenario analysis, they do all of their calculations and then they save the model as a base case scenario, and then they change all of the numbers, and then they save it again as a best case scenario, and then they change all the numbers and they save it again as a worst case scenario. That is not the best way to build models. A better way to do it is to have one version of the model, and then you do a drop down or a switch, or some kind of a manual switch where you're looking between the different scenarios. So like with this, we say base case, we say best case, all the numbers change. We say base case, the numbers change. Worst case, the numbers change, so that you can see each of the scenarios side by side. So something like that. And then similarly, you can sensitivity analysis. What would happen if the square meters were 5,500? Okay, so you can see how that would change. So that's the sort of thing that you can do with scenarios and sensitivity analysis. Now that is not a bad way can often flush out errors in your model. So often, you would expect the prices go up. You would expect that revenue, that our profit margin would go up as well. That sort of thing. If that doesn't happen, then you'd want to know why that could point to some kind of a problem. So scenarios and sensitivity analysis is something, another strategy that you can use. You should be doing scenarios and sensitivity analysis anyway in your financial models, but always trying to use those to flush out a lot of the best practices that that we'll talk about today. And a lot of it is common sense, and a lot of it is for the purpose of reducing errors in your financial models. So next, take note of your Excel errors. And now these are different errors that, a lot of Excel users, when you see errors like this, you think, oh no, something's really gone wrong with my spreadsheet or my financial model. These are your friend. I would much rather see Excel errors like this than to see a number that looks like it's correct, but in fact it's completely wrong. So take note of Excel errors. Embrace your Excel errors. They are not such a bad thing. I would much rather see an error like this than a number that is completely incorrect, and you inadvertently submit some numbers that are completely wrong. So Excel errors are a good thing, and that is why we often say not to use your if error, just like I did in that last example here. So here we actually used an if error. So using an if error formula around it, it's going to suppress errors, and the reason that we've done that here, if I take that if error away from there, let's have a look there. So if I take that away from that and then copy it across, you can see that we end up with a few issues, and that means that our model is not going to calculate. So often we do try not to use if error functions around your formulas if you can help it. In this case, it was kind of necessary. So if you can, we try to show Excel errors where necessary. Now there is one new Excel error that you may not have seen before, and that is a spill error. So let me show you what a spill error looks like. So a spill error is a new type of error that you get with a dynamic array formula. So for example, if you were doing a unique, which is one of my favorite new functions with Excel 365, enter, there we go. So that is going to give you a unique list. Really, really useful. But if you were to do this over here, for example, and it does not have, if it did not have the enough of a range, there you can see that's what the spill error is doing. It's basically saying that there is something in the way, and so that dynamic array cannot do it. So that's the problem there. So if I take that away, then the error is going to write itself there. And the other one you might notice here is a circular reference. Technically not an error, but a circular reference is basically when a formula is linking to itself, and it can often cause models to stop calculating. So let's have a look at what a circular reference might look like. So a really common type of circular reference is, say here, you were picking up C13, and it will tell you, usually it's a lot more complicated than that, but here, yeah, you can see that. When you see a circular reference, generally means if you've done it inadvertently like that, you need to stop whatever you're just doing, undo, close without saving, whatever you need to do to get rid of a circular reference. So having a circular reference in a model inadvertently like this is generally not a very good idea, and you can see there that it's really not calculating properly. It's going to cause all sorts of problems, and you can see here though it tells me at the bottom that it's in C13, so that will help me fix it. But if you inherit a model that's got a circular reference, that's pretty horrible. You open it up and you can see there's a circular reference, things are not calculating properly. The easiest way to find a circular reference is to go to the Formulas tab, error checking circular references, and to just find it there, and that will help you to find it so that you can hunt it down and you can kill it, because that is the best way of dealing with a circular reference. So circular references are generally bad news Are oranges called oranges because they are orange, or is orange called orange because oranges are orange? Who knows? Well, actually, I found out that the colour is actually named after the fruit. So there you go. There is one situation though, particularly in financial models, where we often see circular references, and this is when interest payments will drive profit, and then profit will drive cash, and cash will drive funding, and funding will drive interest, and interest will drive profit, and profit will drive cash, and you end up with the circular reference. And that is a really common structure that we often see when you are linking the P&L, or the profit and loss statement, to the cash flow. We often end up with this kind of circular references, and I know some modelers will say that you should allow iterative calculations, that is okay, that you should have circular references in. You deliberately do a circular reference for that reason. I am not a fan of doing that. You can do a circuit breaker that is going to turn it off. There are lots of other ways of getting around this problem, and circular references would certainly not be my preferred way. But if you did want to do that, if you did deliberately decide that you are going to have a circular reference in a model and you want it to be in there, you would go into File, you would go into your options, and you would go into formulas and enable iterative calculations. I do not recommend it, but if you deliberately wanted to have circular references in your model, then that is how you would do it. And last but not least, in the 10 strategies for reducing errors is error checks. So a good financial modeler is always looking for opportunities to include error checks. So checks will identify errors when using the model, not necessarily errors that are created during the model build. So always trying to think about any possible situation that you could, if you know that this plus this plus this plus this should be equal to that, then that is a good opportunity to put error checks in. So it is usually for other people. I cannot tell you how many times I have got a model back, a model that I build that someone else has been using, and they've the model is not working properly, or they've asked me to take a look at it, and the error checks can tell me that they have not used it properly. They've entered some invalid data, or something has gone wrong with the model, and the error checks will tell me that. So they are more for users using the model build rather than you. For users that are actually using the model rather than you actually during the model build. But sometimes they can flush that out. Error checks should certainly not replace good modeling practice. So let's have a look at an example, or a few examples here, of an error check. So for example, here you've got a stock report. So we've got a total of 36 here. Down here, we've just got a simple sum if formula, and that's going to summarize it in a different way so that you can see there that 36 here should be equal to 36 here. Now that is using one method of doing it. Now my preferred method for doing an error check would just be, it's the simplest, quickest, easier, is that minus that. One cell minus the other. Because of the way I've got this formatted, you can't see it there. I do prefer to perhaps format it like that so that you can see a little dash, or even better to just format it in red. So you have a nice little red dash, so showing that there's possibly a problem. Because if somebody comes along and they put in manual space, I know it looks just like manual, but it's manual space, and that is going to cause an error. So that you can see, it tells me that we are 5 out. You can also do if perhaps this cell does not equal this cell, then you could say error, otherwise okay. That's one way of doing it. Excel does truncate at a certain number of decimal places though, so sometimes I don't recommend doing it like this, because sometimes you might be 0.00000 out, and it will tell you that that there's an error, or it will tell you that there's a false error. So be careful of that. And that is why here we've used, instead, we've said if the absolute value of the difference between the two is greater than 1, give me an error, otherwise okay. So that is probably a better way of doing it. It allows a tolerance for error. It allows us to be $1 out. If you want that to be smaller, you could put 0.1 or 0.01 or whatever you say your tolerance for error is. And the way that we've done this is we've put that in green font, and then we've added some conditional formatting. We've gone into here and said if it's equal to the word error, then it's going to cause, so if that was up there, or if you were to say manual S, something like that, or if we were to say automatic space, something like that. So that's going to, so using some conditional formatting is not a bad way to put in some error checks also. Here's another example of an error check that you might like. So here we've got a little bit more of a more complex model. So you've got your annual sales of just over $3 million, and you've got your phasing. So there's some seasonality that goes out over the next 12 months, and that is up to 12. So we want to make sure that the sales and all of the expenses get spread out over the next 12 months, so that the total amount gets spread. So we want to make sure that there's no errors. So this way here, you can see that the total is spread out. So this error check here is making sure that that number there is the same as that number there. So for example, if that was actually 1.2, if somebody were to make that so that it doesn't add up to 12, so that is spreading it out over the 12 months, it does need to add up to 12, because then otherwise it doesn't spread it out evenly. So that error check is very important for this particular model here. And another example here. So here's another really common problem, something you really should be aware of if you're not already, is that if you were to do a calculation like this, so we're just doing a really simple sum-if formula where we're adding up the region like that, totaling up the sales, and then if somebody were to come along and put in some new data here, let's say Southeast, and we're going to put in 5,000, okay, lovely, and you can see there that it is not being included in our calculations. Really, really easy to do. So, I mean, the error check may, depending on how you've built the error check, it may or may not pick that up. So that is a bit of a problem, something to be really careful of. So always, as you're building your model, always thinking about what could go wrong. How could somebody possibly mess it up? You know, if somebody were to add in some extra data at the bottom, it's all going to fall over. So the way around that, I mean, you could do a sum, this there, that could go further down. Try to resist doing this, where you were to highlight the whole like that. So instead of that, to actually don't go like that. That is not really great practice. It would be much better practice to actually use a table. So if you were to convert that to a table, so to do that you would go Control T, so that's going to convert it to a table like that. It's going to change the formatting perhaps, and you can change the formatting if you like. And you would need to rebuild the formula. So the name of that table is now, so if you click on the table, click away from it, the table design disappears. Click on it, you can see that the table appears like that, and you could call it something else. I'm going to leave it as table 2, and if you were to rebuild that formula, so the range here is this one here, and you could see that it's actually using the range, and then the sum range similarly go all the way down like that. So that is a much more robust way of building that formula, because we know with tables that they automatically expand to include new data. So if I were to add another row down below and say northwest and put like that, you can see here that this formula is automatically including it, whereas this one is not. So that is a better practice way of building it. We often don't use tables for financial models because of the way that the formulas work. So when you drag formulas across, but if you have data that looks like this, if you think that it's more for data collection, if you are going to be using Power BI or Power Query, you have to be using tables, absolutely. When it comes to financial models, we sometimes don't use tables. It really just depends on what you are what you're trying to do. But if you have something like this where you think somebody's going to enter data in at the bottom, then you absolutely should be using a table. So a little bit more on error checks. Absolutely pay attention to errors or Excel errors. Do not ignore them, and pay attention to error checks. If you've built the error checks, you definitely need to have those in there. Don't move on until they get fixed. You might consider using some conditional formatting that will help it to jump out at you. Build those error checks as you go. So wherever you're thinking, so this should be equal to that, then always that's an opportunity to put an error check in. Sometimes what we often do is to create a summary of errors. So to create on one page where you link all of the errors. So most financial models, or certainly my financial models that I build, are often littered with error checks right throughout the model. So what I often do is go through and grab all of those error checks and actually link them through onto one page, and then even have them summarized into one cell. So I can see at a glance straight away if there are any errors in that model. Often when somebody else is using one of my models, I have models that might be around for years and years that I have built, and every now and then the client will send it back to me and say, hey, I've broken it, something is not working. And I'll be able to go to that sneaky little part of the model, and I'll be able to see straight away what's gone wrong. And it will just make it so much quicker and easier to fix. So that was the 10 strategies for reducing errors in financial models. So do think through each of these things as you're building the model. So as you're using Excel to build a financial model, think about using the enter key, checking, and when you've checked the model 3 times, having someone else to check it, validate those assumptions that go into the model, document the methodology, look at doing some stress testing, sensitivities and scenarios, take note of Excel errors, and then of course building error checks. Really important part of financial modeling.